So hello guys, we are dealing with an interesting topic today, conduction, which is a portion of heat transfer. So let us begin with this interesting question कि heat कब transfer होगा. तो दो एस्पेक्ट है, पहले ये बात को समझना है. One, there is a heat absorption and second, there is heat transfer. So right now we are dealing with heat transfer. So what is exactly heat transfer? So heat transfer is the transference of heat energy from a hotter end to the colder end, or from a high temperature source to a lower temperature sink, or if it is a part of the same system, then there must be a temperature difference between 2 points so that heat transfer can take place. If energy transfer has taken place between 2 points and the temperature difference is not there, then we can be sure about one thing, that it was not heat transfer. So this is what the opening line means, that heat transfer involves temperature difference between two systems or two parts of the same system. Any energy transfer that does not involve temperature difference in some way is not heat. Now, once we understand this aspect, that for heat transfer to take place, there must be a temperature difference, we can categorize the modes in which heat transfer take place. So heat can be conducted or transferred in three different ways: conduction, convection and radiation. इसको समझने के लिए मैं एक बहुत पुराना स्टोरी सुनाता हूँ जो बड़ा प्रचलित है. तो स्टोरी ऐसा है, इफ वी हैव अ क्लास फुल ऑफ स्टूडेंट्स और किसी एक स्टूडेंट का बर्थडे है और वो चाहता है कि वो चॉकलेट या टॉफी डिस्ट्रीब्यूट करना चाहता है अपने सारे क्लासमेट्स के साथ, तो वो कैसे डिस्ट्रीब्यूट कर सकता है? पहला तरीका ऐसा है कि वो पूरा बॉक्स ऑफ स्वीट या बॉक्स ऑफ चॉकलेट फ्रंट बेंच पे दे दे, वो स्टूडेंट अपना पार्ट ऑफ स्वीट ले ले और वो ट्रांसफर कर दे दूसरे बेंच पे, वो फिर से अपना पार्ट ले ले, वो तीसरे बेंच पे ट्रांसफर कर दे, एंड ग्रेजुअली द स्वीट will reach the student sitting in the last bench. So this method is technically conduction, where all the amount of heat energy is transferred to the point or to the molecules which are near the source of heat. They absorb their part of energy and start vibrating vigorously, and they transfer the rest of the energy to the neighboring molecules, and as a result of which the heat is transferred from the high temperature end to the low temperature end. The another way by which heat can be transferred or toffees can be distributed is by asking the students to come in line and meet the birthday boy. तो ऐसा हो सकता है कि सारे क्लास के स्टूडेंट एक लाइन बना करके बर्थडे बॉय से मिलने के लिए आए, बर्थडे विश करे, उससे टॉफी ले और अपने जगह पे वापस से चले जाएं. So thereby setting up a convectional current. तो वो जो होगा उसको कहेंगे convection, in which the medium particles are moving from high temperature source to the lower temperature source, thereby setting a convection current, and the process of heat transfer is called as convection. और तीसरा एक तरीका है, थोड़ा अनरूली तरीका है. तीसरा तरीका ऐसा है कि बर्थडे बॉय खड़ा हो जाए सारे टॉफी और स्वीट लेकर के और वो अपने जगह से हीट यानी कि एनर्जी को फेंकना स्टार्ट करे सब स्टूडेंट की तरफ और सब कोई अपने अपने पोर्शन का एनर्जी कैच करे. ये जो तरीका है ये हो गया रेडिएशन, in which a source of heat is there or a source of energy is there and it is just radiating heat in all directions, and we act as a receiver and receives heat which are at the lower temperature end. So this is how conduction, convection and radiation is classified and can be understood easily. Now let us get into the intricacies of conduction. So what is exactly conduction? So as I already mentioned, in conduction, energy is transferred from hotter end to the colder end without the dislocation of the molecules. That is, the molecules are not moving, the students of the classroom are fixed at their own places, and the energy is transferred one by one by transferring the energy from hotter end to the colder end. So this is what convection means. That is, we can say that for heat to be transferred or toffees to be transferred from one end to the another end of the classroom, the presence of classmates are very important. That is, we can say that conduction can only take place in the presence of material medium. Somebody must be there, otherwise the toffee transmission cannot take place. So this is how we define conduction. Now let us get into the mathematics of conduction. So over here, we have a high temperature end TH and a colder end TC, and we say that the heat is getting transmitted through this. One thing to understand over here is that we are discussing heat transmission and we are not talking about heat absorption right now. And as I already mentioned, there are three modes of heat transfer and we cannot say that right now only conduction will take place. तो अपने इसको अगर इस तरीके से समझे कि over here, suppose we have a higher temperature end, say at 100 degrees Celsius, and the colder end is at 0 degrees Celsius. We also need to understand that while the heat is transferred, the temperature of the source and the temperature of the sink, or I can say the higher temperature end and the lower temperature end, are not undergoing any change in temperature with the transfer of heat taking place. मतलब कि ये पहले भी 100 डिग्री सेल्सियस में था, ये पहले भी 0 डिग्री सेल्सियस में था, ये बाद में भी 100 रह जाएगा, ये बाद में भी 0 रह जाएगा. The transfer of heat will take place, and this process is such that the heat flow is taking place in a steady manner. When I say in a steady manner, इसका मतलब क्या हो गया? इसका मतलब ऐसा हो गया कि जब ये 100 डिग्री का एंड है और ये 0 डिग्री का एंड है, तो डेफिनेटली यहाँ पे कोई एक पॉइंट होगा जिसका टेम्परेचर 80 डिग्री होगा. यहाँ पे डेफिनेटली कोई एक पॉइंट होगा जिसका टेम्परेचर 30 डिग्री होगा. एंड इफ आई से that the outside temperature is 20 degrees Celsius, then definitely heat must be radiated out from 90 degree or 80 degree end to the surrounding. So we are considering that right now this entire conductor is laminated with a coating so that no heat transfer is taking place through radiation and only conduction is taking place. That is, heat energy is conducted from this end to this end. Now gradually the temperature of each end must get fixed. So at T equal to 0, when the conductor is placed between a hotter end and the colder end, all the temperatures at different points do not get fixed eventually, but it takes certain time for the heat at each end to get fixed. That is, a steady state is reached. Once a steady state is reached, we can think of writing an equation. Now we are also considering that the material is made up of one single material. That is, I can say that either this is a copper rod or this is an iron rod. It is not a mixture of two. It can't be this way that over here at this end 100% copper is there and at the other end 100% iron is there, and the quantity of copper is going down and quantity of iron is rising up. We are not considering a rod like that. We are considering an isotropic material. That is, एक ऐसा मटेरियल हो जिसमें पूरे के पूरे कॉपर हो या पूरे के पूरे आयरन हो, तभी अपने कहेंगे कि टेम्परेचर ग्रेडियंट जो है वो कांस्टेंट है. सो ओवर हियर वी कैन से दैट द टेम्परेचर ग्रेडियंट एट दिस पॉइंट, जैसे कि मैंने कहा ये हायर टेम्परेचर एंड है, ये कोल्डर एंड है, तो टेम्परेचर ग्रेजुअली डिक्रीज कर रहा है हर एंड पे. तो वी कैन से कि अगर ये वाले एंड पे टेम्परेचर T प्लस dt है और यहाँ पे T है, so there is a fall in temperature dt as it covers a distance dx, and this is regarded as temperature gradient. Temperature gradient. और हम लोग एक बात देख पा रहे हैं कि in the flow of heat taking place from higher end to the colder end, the temperature gradient is negative. यहाँ पे अपने इसको अगर ग्राफिकली भी देखें तो अगर ये हॉटर एंड है और ये कोल्डर एंड है, तो इसका जो स्लोप है which is representing temperature gradient is negative. To omit this negative part, we are writing the equation of flow of heat. So we are writing Q, which is the rate of flow of heat. Now this must be kept in mind that this rate of flow of heat is measured in what? We are not talking about the energy transfer taking place. We are talking about the rate of energy transfer taking place, which we are measuring in watt or joule per second. So over here we say that the rate of energy transfer taking place is proportional to temperature gradient. It is also proportional to the cross section which is exposed, and hence when we write the final equation, we write it as Q equals minus Ka dt by dx, where K is representing the material which is conducting material involved here, and the parameter is called as thermal conductivity of the material. तो ये जो है ये प्रॉपर्टी ऑफ मटेरियल है और इसका एग्जांपल अगर अपने ले लें तो वी कैन से दैट K फॉर कॉपर इज डेफिनेटली ग्रेटर देन K फॉर आयरन ग्रेटर देन K फॉर वुड. So we can say that copper is the material of highest conductivity, wood is the material of lowest thermal conductivity, and this is how we write the expression for the rate of heat flow taking place. Now, over here we have an interesting thing to note that there is an analogy between Ohm's law and heat transfer or conduction equation. So over here we can say that if there is a higher potential and a lower potential, and a current flows from higher potential to lower potential, then using Ohm's law, we can write potential difference is equal to IR. And R, which is resistance of the material, is written as rho L upon A, when rho is resistivity of the material. Again, rho is property of the material. Rho is different for different material. Resistivity is least in case of conductors and most in case of non-conductors. So resistivity of the material, length of the conductor, and the cross section through which current flows. So we write resistance as rho L upon A, and then we have this expression of Ohm's law. So here the expression which we have written can also be deduced from the analogy of Ohm's law. We can say that the higher temperature end and lower temperature end is serving as a mean of gradient, which is called as temperature gradient in this case, and this is responsible for Q, which is rate of flow of heat times thermal resistance. And to write thermal resistance, we are using the same concept as rho L upon A. So rho का reciprocal हो गया resistivity का reciprocal conductivity. So we write it as L upon Ka, and the equation will take the form Th minus Tc is equal to Q L upon Ka, and if we want to write it in this form, we can write it as Ka Th minus Tc by L. So we can write this equation in this form. So this is the equation for heat transfer taking place through conduction. This is the more easier way of writing the equation. We need to understand that the area which we take is the area perpendicular to the flow of heat. So perpendicular to the flow of heat, which is from hotter end to the colder end, we will take the area which is perpendicular to the flow of heat. K is thermal conductivity of the material. We can quickly determine the unit for thermal conductivity of the material. Thermal conductivity of the material is measured in watt per meter per degree Celsius. Or we can say watt per meter per Kelvin. So this is an introduction to heat transfer and the concept of conduction taking place.